Stun, stun, stun!
I'm on it!
Catch!
Oh yeah, baby!
Yeah, as if we did when I didn't tell for how to do.
Yeah.
But actually, GG.
Oh shirt! That's just tomorrow.
Say what? We just finished chapter 5 yesterday. Oh,
Yeah, just tell me you study. Please!
me? Study?
Okay, 6 hours left if we crashed all night.
Or cheat?
Yeah, let's cheat.
Operating campaign codename Cheat for Life.
Please report the situation.
Roger. At any given point in time, Mr. Sniper can be at his table 90% of all times, which means that that makes you have the probability of getting caught of about 87%, and that of mine is 99%. But when he's not at his table, your probability of getting caught rises to 99%, while mine decreases to 90%.
Wait. What's the probability again?
The probability of an event refers to the likelihood that the event will occur if the event is repeated many times. You're screwed if you don't even know the definition of that.
You don't say? Anyway, Mr. Sniper is pretty sharp, isn't he? But come on, with so many kids, what's the probability of both of us, or at least one of us, getting caught if we don't set each other out or whatever?
We need some calculations.
Oh yes, we do. I know some basic rules right here.
Wait. You're saying that you don't know the definition of probability, but you know its rules?
Yeah.
Say what? Okay, forget it. Time is running out. But with all due respect, could you explain those fancy symbols in normal English, which I can understand?
Did you even pay attention in class?
Well, if checking your tweet counts.
Anyway, P8 is a notation for probability of an event A. For example, if the chance of you getting caught is 0.99, then P Zal equals 0.99.
Alright, that sounds legitimate.
Jing jing jing! Wow, you already catching on. Since the first rule is legitimate values, the probability of one event must be at least 0 and at most 1.
Oh, because the event A will not occur, and at most it will for sure occur. So when you said you're 200% sure of the existence of unicorns, you lied? No!
We were 6! Come on!
Wait. So that also means those probabilities of all possible outcomes of an event have to add up to 1?
Exactly. You know how the classic problem of probability is tossing a coin and the results are always head or tail?
What if the coin lands on its side?
Come on, just follow the problem, okay? Anyway, the total possible outcomes is always 1.
Prove it!
Okay then, I'll use sample space.
Huh?
Sample space, the set that contains all the possible outcomes of an event. Okay, let's say you toss a coin 3 times. Your sample space would be head, tail, 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 head, tail, head, tail, tail, head, tail, tail. Now, there are 8 outcomes and one of them is 3 heads. So the probability of 3 heads is 1 over 8. Can you find the probability of at least 2 tails?
Yeah, it's easy. Looking at the sample space, we can get 3 over 8.
Nicely done! So do you know what's the probability of getting 1 or less tails?
Well, getting 1 or less tails means head, tails, head, tails, heads, tails, heads, tails. And the possibility equals to 5 over 8?
Correct! Do you notice those probabilities add up to 1?
Yeah. Wait! Is that the "you're so beautiful" rule?
Nope! It's a complement rule, not the complement rule. Like, you spend an hour in class and you remember this joke only? Whatever. The complement rule states that the probability of an event will occur is equal to 1 minus the probability of that event will not occur. Therefore, the probability of getting at least 2 tails and not at least 2 tails, in other words, getting 1 or less tails, is 1.
I get it. Then with our situation, the probability of me not getting caught is p Zal complement equals 1 minus p Zal, which is 1 minus 0.99 equals 0.01.
True, but our problem is not that easy, for sure. Since we want to know the both percentage of us, or at least one of us, cheating yet not getting caught, we need the general rule. It states the chance of one of or the other event happening is equal to the chance of both events happening minus both events happening simultaneously.
Say what?
Okay. For instance, the probability of one of us getting caught is P Zal on Yim equals P Zal plus P Yim minus P Zal and Yim equals, well, you can see the calculation 0.9987.
Hold up. So you're saying that the probability of two events happening simultaneously always equals to the product of the events' probabilities?
Nope. The chance of two events happening at the same time will equal to 0 if two of those events are disjoint or mutually exclusive.
Thank you, Captain Obvious. They can't occur together. The chance of them happening together is 0. Duh.
Okay. Then it will equal the product of two events probability only if those are independent of each other, and it will equal to a given number if they are dependent on each other.
And the given number is?
Well, this kind of exercise will likely to give you a table to calculate the probability. Like this table, which I snatched from the teacher's desk, displays data on 300 students' gender and whether they have cheated on a test. 4 small questions incoming. Okay, so first of all, what's the probability of that student being a male? What's the probability of that student has cheated? What's the probability of that student being a male or a cheater? And are the events male and had cheated independent?
Well, for the first one, it's 165 over 300.
Ding ding!
For the second one, P had cheated is 45 over 300.
Yeah, you got it right.
For the third one, applying the general rule, P male or cheater, let's see, that's equals to P male plus P had cheated minus the P male and had cheated is equals to 0.6175.
Okay, Zal, remember, since we do not know whether the two events are independent, we can't assume that P male and had cheated equals P male multiplied by P had cheated. Rather, based on the table, we have P male and had cheated equals 15 over 300. So, with the calculation for P male or cheater, we will have 0.65%. Do you see a large difference?
Oh yeah, but I think I got the hang of it. What about the fourth one? I don't want to do the whole chi-square test. Mate, come on.
Nobody got time for that. The answer is simple though. Checking whether P male and had cheated equals P male multiplied by P had cheated, because the chance of two events happening at the same time will equal the product of two events' probabilities only if those are independent of each other. Since 165 over 300 multiplied by 45 over 300 different from 15 over 300, the events are dependent on each other.
It's funny how the table suggests that girls cheat way more than boys. Lol, in your face, Neem.
Made up data, honey. After all, 97.3% of all statistics are made up.
Oh. I'm just curious though. Suppose that this table is true. Given that you're a girl, what's the probability of you had cheated before?
Yeah, we need to take that into account too. I mean, if you get caught, will my chance of getting away higher or lower?
I don't like this, but let me think. Got it. Conditional probability.
Huh?
Well, conditional probability is the measure of the probability of an event A given that event B has occurred and calculated by P A if B and P A and B divided by PB. For example, based on the table, event A is had cheated, event B is girl, and
Wait, I think I can give it a try. So then the probability of you had cheated before if you are a girl is P had cheated if girl equals P had cheated and girl over P girl, right? So 15 over 300 divided by 135 over 300 equals 0.11.
amazing! You're fast. But you know, even with this bunch of knowledge, I still don't know how to deal with our actual problem.
Hashtag feel complicated and confused, man.
I know the answer to our problem!
I probably think about that too.
Tree diagram.
Duh. Yeah, it's perfect for these events because they are independent.
Nice. How could we forget about the most basic diagram for probability?
I know, right? Okay, let's get to work. Come on, come on.
Okay, so we had 3 events. Each one has 2 outcomes. So our tree diagram is like this.
So our first event should be whether Mr. Sniper is at his desk or not. Since Mr. Sniper can be at his table 0.9 all times, the chance of him not being there is 1 minus 0.9 equals 0.1.
Okay, with these first 2 branches, each branch will have 2 smaller branches, resembles either you get caught or you do not. With Mr. Sniper at his desk, they're going to be in order 0.87 and 1 minus 0.87, 0.13. And this branch, where Mr. Sniper is not at his desk, will make your chances 0.99 and 1 minus 0.99 equals to 0.01.
So with Mr. Sniper at his desk, your chances are 0.99 and 0.01. While Mr. Sniper roaming around, your chances are 0.9 and 0.1.
What a massive tree diagram. Usually there are only 2 independent events only.
This is real life, Zal. These calculations will tell us whether we can fail to reject HO, we can get away happily, or not, suggest as HA, we get caught with significant evidence.
Alrighty then. While you're ranting, I'm done with these calculations by multiplying out the probabilities for each small branch. Okay, for example, each branch means that the probability of Sniper at his desk, you getting caught, and I getting caught, is 0.9 multiplied by 0.87 multiplied by 0.99. And it equals to 0.78.
Just hurry up and tell me the chance of us getting away already.
Rest that chest, woman. I'm trying to figure it out here. So the chance of neither of us getting caught is 0.9 multiplied by 0.13 multiplied by 0.1 plus 0.1 multiplied by 0.01 multiplied by 0.1. Wow. It equals to 0.0011.
That's even if we use the lowest alpha level at 0.01, we still have to reject HO. There's enough significant evidence to suggest that we will get caught. We are doomed.
I know. I also tried other probabilities too, such as given that Sniper's at his desk, the probability of both of us getting away is 0.0013, and that of when Sniper's roaming is 0.001. For me alone, the chance of not getting caught is extremely low, 0.00211, but you have a high chance of succeeding.
Zal, you know it's 14%. Too risky, I'm telling ya. And if I have an F, my dad, who is an Asian, you know what will happen, right?
Disown. KO.
And no cheating then. You know we should have spent these 6 hours to review, not to calculate this chance of getting away.
We tried so hard and got so far. In the end,
It doesn't even matter.
Take a seat. Take a seat! Guys, no test today. I messed up.